Okay, so let's start today's class. So first let us do a quick revision of what we have already done in the previous class. So in the last class we talked about method overloading. So what is method overloading? It's a feature that allows us to have functions with the same name. So it is a feature of object-oriented programming that allows us to have functions with the same name but with different number or type of arguments. Rather, you should call this parameters, type of parameters. So method overloading is nothing but functions so they are nothing but functions with the same name but with different number and type of parameters. So again, where is the difference? The difference lies in the function signature. Function signature is nothing but the first line of a function definition. So let's say if I have a function called void fun and I have parameters, say int a, float b, and there is something written inside this function. So this particular line is called the function signature. These are the function parameters, and method overloading says that we can have multiple functions with the same name. So I can have another function called for void fun that has the same name as the previous one, except that the number of arguments are different. So the first function has two parameters, and the second function has a single parameter. So I can differentiate both the functions, although they have the same name, but I can differentiate, or rather the compiler can differentiate with this thing. There are two parameters here and there is just one parameter here. So when I'm calling the function, if I'm passing one argument, then this function is executed. If I'm passing two arguments when I'm calling the function, then this particular function method is, executed. Again, there is one more way. Let's say I have a third function which is also called void fun, and I have double a string b, and there is something again written inside. So here again you see this particular function and this particular function has the same number of parameters. So they have one two parameters, and here also there are two parameters, but the difference lies in the type. The difference lies in the type of the parameters. So as you can see, the functions may have the same name, but they must have different number of parameters or different type of parameters. So the number of parameters in both the first function and the third function is same. This one also has two parameters. This function again has two parameters, but the type of the parameters are different. This has int and float, this has double and string. Okay, and compared to the first one, the second function has, so in this example in these two examples, this particular point is made clear. That is, if the number of parameters are same, it is differentiated using the type of the parameter, as in the data type of the parameter. And considering these two, this example and this, the first one and this, or the third one and this, so these, either this one and this one, or this one and this one, whichever you may consider, the difference lies in the number of parameters. So this has two parameters, this has one parameter. Again, this has two parameters, this is one parameter. So the main way to differentiate is, so overloaded functions are differentiated using two ways. One, the number of parameters. Two, the type of parameters. So overloaded functions can be differentiated in two ways. Just wait a minute. Okay, so overloaded functions can be differentiated in basically two ways. First, the number of parameters. Second, the type of the parameters. Let's take a look at an example. Let us go back to the previous program that we had done, the calculator program. And let's just modify this program to implement function overloading. So previously, if you remember, this program could only work upon floating point numbers. So I had to always give, decimal numbers to do any type of operation, be it addition, subtraction, multiplication, or division. So let's try overloading and see if we can work with integers as well as floating point numbers. So there will, once I modify this program, the user will not need to make sure that he always enters floating point numbers. He can also work with integer numbers. So how will I do that? Let's take a look. So more variables of type int. So let's call it x2 and y2. I cannot name them x and y as well because variable names must be different. So for the sake of clearance, I'm calling the floating point variables or the float type variables as x1 and y1. I'm calling the integer type variables as x2 and y2. So I also need to initialize the integer variables that I just defined. So these will become x1, this will become y1, this will become x2, and then again y. So I've initialized all four variables. Now I'll just change the names accordingly. So these are my float variables that I'm currently changing. So this is just the previous program. I've just made one modification, that is this, if you remember, this method was declared as a returnable method. So this was type float, and there was a return statement inside the method, which I have converted to a non-returnable method. So I've defined it as void. I've removed the return statement from here, and I have inserted a SOPLN statement so that the function is done here itself. The displaying part is done here itself. Just for the sake of simplicity, I have just changed the returnable functions to non-returnable ones. So I'm changing all the variable names to x1 and y1. And that is all. So this is just the previous program with a few modifications. I've changed these two methods to non-returnable type. So these were returnable methods which returned a value. I've changed them to void type, so they do not return a value now. I've declared uh, two more variables. I've changed the name of the variables, previously defined variables. So x is now x1, y is y1, and now I'm going to implement method overloading upon this program. So I've defined two more variables for integer calculations. I've initialized those two variables. Now I will just write a overload. So I'll first overload the add method. So I already have add to add two floating point numbers. Now I'll have another add function, add to integer numbers. So as you can see, both the functions have the same name as well as the same number of parameters, but the type of parameters is different. Okay, is it clear now? So now is it clear? Okay, just let me check once. So how is it now? I think I should bring this down a little more. So is it clear now? I hope it's clear now. Now it should not echo now. Previously I had some background noise. So Okay, so now it should not echo anymore. Okay, good. So as you can see, I'm just doing the same thing except that I'm working with integer variables now. And the system.out.println statements here, I'm just doing a little bit of outline so that it looks better. So once I run the program, to see how it comes out. So I do not need to worry about this variable and this variable having the same name because they are local to this function. This float variable is local to this function and this float variable is local to this function. So now I have overloaded the add method. So one add will add two floating point numbers. The other add function will add two integer numbers. This will depend on how I am passing arguments to this function. So the compiler will automatically select one of these two. If I'm passing an integer argument, it will call this method. If I'm passing a floating point argument, it will automatically call this method. Now, let's overload the other method. So let's move on with the subtract method. So I'll just copy a few things so that too much time is not taken up for typing. Instead of float, I'll have int now. And also I'm copying the code inside. So instead of x1, this should be x2, should be y2. Similarly here also it should be x2, y2. The type will be changed to int, and this will become x2 and this becomes y2. And I have successfully overloaded my subtract method. Now let's move on to the multiply method. I'm just copying this whole thing. Now just change everything. So this becomes int, this too becomes int, this becomes x2 again, y2, this should be int. And that's it. Also the divide method, I'll just copy it once again. And I'm going to paste it as well, changing the data types to int, changing the variables accordingly, changing this to int, again changing the variables. So now as you can see, I had 4 methods previously. Now I have 8 methods. So two of each have the same name. So there are 2 add methods, 2 subtract methods, 2 multiply methods, and 2 divide methods. So each of them work differently. The first 4 methods, as in add, subtract, multiply, and divide, work on floating point numbers, whereas the second type of methods act on integer numbers. Let's compile this. Okay, It's done. Now let's modify the class with the main program. So this was my class that contained the main program. I have already defined an object. Now let's just use the object to call the methods. Since the methods are non-returnable type, so I do not need any variables. I'll just call them and it will directly display the results. Let's add two floating point numbers first. Now let's add two integer numbers. Let's do the same for the other operations as well. So we'll just copy the same values multiply and lastly I have the divide method. So dividing 5 by 4 will give me a floating point number. So let's divide 5 by 100. Let's see what happens. So again I have c1 dot divide and 5 by 100. So that's my program. Now let's run the program and see what kind of output we are getting here. So adding 5 and 4, which were floating point numbers, so I get 9.0. Again, see, I'm calling, take a look here. So what's happening is that, so in this line, what happens is that I'm calling the same method add, and it's adding two floating point or floating type variables or values, floating point values. Again, in this line also, I'm calling the same method add, as in the user will see that the user will feel like he's calling the same method add, but it is adding two integer values. So the add method adds two floating values as well as two integer values. So this is how a function or a method is overloaded. Again, here again using the subtract method. So this has been done using the subtract method. This has also been done using the subtract method. So I'm calling the same method, but I'm working on two different data types. One is the floating point type, another is the integer type. But it's working. It's working by calling the same method. So that was what I was trying to explain. So in this particular example, the type of arguments were different. Number of arguments were same, as in each method had two parameters. So all the 8 methods had 2 parameters, but the type of the parameters were different for the overloaded functions. So again, let's take a look once more. So as I told you, there are two ways to differentiate between overloaded methods. Take a look at these two methods. So the number of parameters is same. This also has 2 parameters. This divide also has 2 parameters, but the type is different. The first divide has floating type parameters. The second divide has integer type parameters. Okay, so that's how floating point operations, function overloading is differentiated. I hope this particular topic is clear. So there's nothing else apart from this in function overloading. You just need to remember 3 points. So method overloading. What is method overloading? Same functions. So the definition would be same functions. Sorry, not same functions. Um, Functions having the same name. Functions having same name, but first point is different number of parameters, and the second point is different type of parameters. So method overloading or function overloading is nothing but functions having the same name but 2 points, different number of parameters, and different types of parameters. So that's how you overload a method. We'll be looking at further examples in the coming classes. Now let's move on to a new topic, that is how a Java program actually works internally. You just type a program in BlueJ. So we have BlueJ here. So you just create a new class, write something inside the class, compile the class, and run the program using your mouse. You just click and do everything. But how does it work internally? So this is a part of basics. So let's take a look at what happens during compile time, or rather, when you compile the program, what exactly happens behind the scenes. So at compile time, the Java file is compiled by the Java compiler. It does not interact with the OS and converts the Java code into bytecode. So the job of the compiler is to convert. So the job of the Java compiler is to convert source code to bytecode. This source code is nothing but this is the program that you have written, programs that you write. Bytecode is the compiled program. So if we draw it in this way, so there is the source file, which is the program file that you have written, as in the class file, or rather the file that uh, there'll be a file called, let's say I have a program called p1. So the file p1.java is my source file. So this is my source file. I have the compiler in the middle, which compiles the program and converts it into bytecode. So I give the compiler a source file, it compiles the source file and changes it into bytecode. But there's one point that you need to, focus upon, is that the compiler does not work on any hardware. It works on a file. The compiler has no relation whatsoever with the hardware. As in it does not work with the hardware. It does not use your it does not use your processor, rather it uses the processor to compile, but basically it is not used to run the program. So compiler does not actually run the program on the machine. It just converts it into corresponding bytecode. So that's what this particular thing means. It does not interact with the OS here. When do I need to interact with the operating system? When I'm running something. Whenever something runs on the computer, so that application but interacts with the operating system. So here a Java compiler does not interact with the OS, it just compiles. Simple. You give it a source code, you give it a source file, it will compile it into a bytecode file. So if the source file has an extension .java, the bytecode will have an extension .class. These 2 points are important to remember. So your source files will have .java extension, and the compiled bytecode correspondingly will have the .class extension. Now what happens at runtime? So previously when we studied basics, um, a Java program had two to run a Java program. There were two processes involved. One was compiling, and then the second process was running the program, actually running the program on the machine. So compiling is done by the compiler, and running the program is done by the JVM, which stands for the Java Virtual Machine. So you have already studied about what is the Java Virtual Machine. So running the program is run in this particular thing, the Java Virtual Machine, and it is compiled using the compiler. So it's a two-step process basically at the beginning. So what happens at runtime? Let's take a look. So the runtime steps are as follows. So now I have, finished. So my compiler has run. So I have got the class file after running my compiler. So I already have the class file as you saw in the previous step. So I have the source code. I run it through a compiler and I get the bytecode, which is simply my class file. Now, while running, I'll use the class file. I'll no longer use the source code. I'll not use the source file. When I'm running the program, I'll use the compiled bytecode file. So bytecode file has a .class extension, so that is basically the class. This is basically the bytecode that I've generated after compiling. So the bytecode passes through a series of steps. So these are basically the steps. You don't need to remember all the steps. Just know that on compiling the source code, using a compiler, I get a bytecode file. When running the program, this bytecode file is used. So there are certain steps involved. The bytecode is verified. The class loader basically loads the class file or the bytecode file. So class loader loads it into memory. The bytecode is verified there by the bytecode verifier. There is a program that verifies the bytecode. Next, there is an interpreter. So as you might have heard, Java is both a compiled and an interpreted programming language. So it is compiled as well as interpreted. We have learned about a compiler and an interpreter. We have also um, discussed and learned about the differences between a compiler and an interpreter. So the compiler basically converts the whole program to bytecode as a whole, so it does not work line by line. A compiler takes the whole program as an input, the source file, and compiles the whole thing into bytecode. Whereas the interpreter will take the bytecode and run it line by line. So the interpreter line runs, so this particular program runs the bytecode line by line. So what it does, the interpreter picks a line from, let's say uh, I have this bytecode file. So there are 101010. So there are many one zeros, one zeros. So bytecode will be like something like this. So the interpreter will take the first line, send it to the runtime. The runtime will send it to the hardware and it will run. Next, it will go to the second line, again execute the second line. Then it will go to the third line, execute the third line, and so on. So the interpreter basically executes the bytecode line by line, starting from the first line and going forward like that. So what is a class loader? A class loader is basically a part of JVM. Subsystem means a part, so you do not need to remember this particular term. Just remember class loader is a part of JVM, which is used to load the class files. So the JVM has certain parts. So one is the class loader, loads the bytecode into memory. So by loading, it means that it loads the bytecode into RAM or memory for the execution to begin. So it loads the bytecode. So the class loader does what? It loads the bytecode or the class file. This is also known as the class file. That is why this is called the class loader, since it loads the class file. So this is a part of JVM. The bytecode verifier is again a part of the JVM. So there is another part called the bytecode verifier. This is nothing, this works similar to, let's say, when you order something online and the product comes, the delivery guy comes to give you your product. So you obviously verify your products before receiving and signing the uh, signing it and then receiving it. So this particular thing, basically what it does is the bytecode. So consider the bytecode as a package that the machine had ordered. And the bytecode verifier, what it does, it verifies the contents of the package. So this basically verifies the contents of the class file slash bytecode file. Okay, so the JVM has a class loader which loads the class file or the bytecode file, has a bytecode verifier which verifies the contents of the class file and the bytecode file to check if there is any problem or not. And lastly, there is the interpreter. So the JVM basically has three parts. There are certain other parts, but we do not need to go into such detail. You just need to know these three parts. The JVM consists of a class loader, which loads the class file, a bytecode verifier which verifies the bytecode or the class file, and the interpreter which executes the bytecode line by line. There's one more interesting thing to remember, or rather, there's one more thing that you have already heard about, but you might have not thought about it so much so in detail, is that when we are talking about errors in a program, there are basically two kinds of errors. One is the compile time errors. So errors can happen during two times. One is during the compile time, one is during the runtime. Right. So compile time errors happen during compilation or during compiling when I'm compiling the program, when I'm working with the compiler. Runtime errors happen during this stage when the bytecode is being executed by the interpreter. Okay. So compile time errors, there are basically three types of errors. We are presently considered, we are presently bothered about the first two types. The compile time error will happen during compilation. The runtime error happens during this particular stage when the interpreter is running the bytecode or executing the bytecode. At that time, the runtime errors happen. If you remember, there was one more type of error which was called logical error. Logical error was nothing but an error on the programmer's part. Okay, wherein let's say I wanted to add two numbers, but I have by mistake divided the two numbers. So that's a logical error. Compile time errors are basically considered with syntax. So compiler basically checks the syntax. Syntax checking is done here, as in whether you are following the rules of the programming language, like whether you have used semicolons, double inverted commas wherever it's necessary, whether you have defined all the variables. So these are syntax checking. These are called the syntax, which is checked during compilation by the compiler. Runtime errors basically happen, let's say, while running the program, you suddenly run out of memory space. Let's say you're running a huge program, but your program, you have been sloppy and you have written the program in such a way that it uses a lot of memory. But on the other hand, you do not have that much memory. So what happens while running the program? At first, it will run for some time because, as you know, the interpreter executes it line by line. So let's say after the first four lines, I come across a line which needs a lot of memory. First four lines execute as it should. On coming to the fourth line, it gives me an error suddenly that I'm out of memory or the machine is out of memory, something like that. So that type of error is called a runtime error. It happens during the execution of the program when the interpreter is running the program. So remember these three parts. Remember the it's best if you could remember the whole process. So let me summarize the whole thing once. So I have source code, which is compiled by the compiler to bytecode, which is when I'm running it is loaded by the class loader into memory, which is RAM. So the bytecode is loaded by the class loader into memory, which is RAM. Now the bytecode verifier comes into play, verifies the bytecode. What happens on successful verification? So the bytecode is verified. Next, I have the interpreter which runs the program. So this is what you could say a flow chart or a flow diagram. So starting from the source code, it is fed inside the into the compiler. The compiler generates bytecode. So syntax checking is done here by the compiler. After that, it's converted to bytecode. Right now, this part is called the, or rather, this part. So this is my JVM, and this particular part is my compiler. So this is a summary of how a program runs internally, or what happens behind the scenes. So I have source code, compiler checks for syntax errors, compiles it into bytecode. Now it is passed on to the JVM where I have a class loader. Bytecode is loaded by the class loader into memory where it is verified by the bytecode verifier. So once the bytecode is verified, it is fed inside the interpreter, and the interpreter runs or executes the bytecode line by line. So this is the summary of how a program runs behind the scenes. So how a program runs internally. So this is how a program runs internally. I hope this particular thing is clear. Let's talk about one more thing. This will be short. Um, After this, I'll end the class for today. So there's one more thing apart from how a program runs internally. You'll also have to remember this. So this is the list of keywords that are there in Java. There are in total 48 keywords. Most of the keywords you have already used while writing your program, but there are certain other ones which you will have to remember. So these are just one-line definitions of the keywords, as in what they do or what they are. You have already, excuse me, you have already used Boolean, you have already used break. Um, you know what is a byte when you have studied data types. You have already used the case. When you have studied about switch case, we had used this particular keyword. Then you have already used char, you have used class. We have also studied about continue. It's the opposite of, and it should not be called opposite. Rather, it comes when we had studied about break, we had also learned about continue. What does continue do? It basically skips the present iteration of the loop and moves on with the next iteration. So it's basically used to continue the loop, which means skip the present loop that you are running right now and continue with the next loop, next iteration rather. We have already learned about default in access specifiers. We have also learned about do in do while loops, double, else. Um, Moving on, I have also discussed final, which is an access non-access modifier. Float, for, if, import, int, long. Native we have not studied, new, null also has been done. Package has not been done yet, so private has been done. Protected has not been done yet. Um, you do not presently have protected in your syllabus, but it is also a kind of access modifier, just like private, but there are certain more limitations. So we'll be learning about this later on when we have that in our syllabus. We have also learned about public. We have used public. We have used return. You know what is a short type? It is a data type. We have used static. We have used the switch keyword in switch case. We haven't yet used this keyword. We'll be studying this later on. We have briefly seen the use of throws when we use the buffered reader class. So we have already come across the keyword throws. We have come across void and we have come across while. So most of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So more or less 29 to 30 keywords you have already used in a program, or rather heard or seen them being used in a program. The rest 18 keywords that we have not yet used, just know what the keywords are. Okay. What they do, just if you know it a little bit, then it's good. But if you don't know, then you must know the what the actual keywords are. If you do not know what they do or how are they used, it doesn't matter, but you must know the keywords so that you do not use them while naming variables and classes. So we have already covered 29 to 30 keywords out of the list of 48. Further, as we go along with our classes, we'll be studying 2, 3 more, and later on in the next class, we'll be studying the rest. So this is the list of keywords. So make sure you take a note of all the keywords that have already been done. And the rest will just suffice to know the names of the rest. So um, that's all for today's class. So we have talked about overloading, we have learned about how a program runs internally, and we have learned certain keywords. So we know now there are 48 keywords in Java, and we have already used 29 to 30 of them. So in the next class, what we'll be doing is we will be learning about JVM, JRE, and JDK. So we'll be learning about JVM in detail, and I'll be mentioning JRE and JDK. So these two particularly are asked during Viva when you'll be having your board exams. And we will also talk about the Java data types. We'll just revisit Java data types and we'll talk about JVM, JRE, and JDK in the next class.